Let's look at another example. I'm going to look at my x values, see how they're changing. I see going from 5 to 10, I'm going up plus 5. From 10 to 15, I'm going up plus 5. And from 15 to 20, I'm going up plus 5. So this is a little bit different than our previous example when x's were just going up by once, but that's okay. Now my y values from 40 to 30, I'm actually going down minus 10. From 30 to 20, I'm going down minus 10. And from 20 to 10, I'm going down minus 10. So the y values are also different because before they were increasing, now they're decreasing. I'm not too worried either way. So first thing I want to do is I want to find the rate of change, which is the change in y over the change in x. And I already said my change in y is negative 10 or minus 10 each time. So I'm going to put negative 10 for my change in y. You have to put that negative there. It's very important. And my change in x is positive 5. So I'm just going to put a positive 5. You don't have to put the sign again because we assume that's a positive number. Now I can simplify this. Negative 10 divided by positive 5 is negative 2. So when I'm making my equation, and it's going to be y is equal to, and we're going to have x on this side with some numbers, again, my rate of change, in this case negative 2, goes in front of the x right away. So y is equal to negative 2x. Let's see if this works. If I plug in 5, will I get 40? Well, negative 2 times 5 is negative 10. That's not the same as 40. So I know my equation is not complete yet. I still have that constant that's going to come afterwards. I just don't know what that constant is going to be. Again, the constant is the y value when x is equal to 0. So if my x's are going up by 5 each time, to go backwards to get to 0, I would have to subtract by 5. And that would give me 0. Now I want to find the corresponding y values. My y values are going down by 10 each time, so to go in the opposite direction, I would add 10. And 40 plus 10, 40 plus 10 is 50. So my y value when x is 0 is 50. My constant would be plus 50. So I think my equation is y is equal to negative 2x plus 50. Let's see if this is going to work. So we have y is equal to negative 2x plus 50. I can actually choose any of my x values to plug in, but usually we want to pick the smaller numbers just because the calculations will be a little bit easier. So I'm going to choose 5 at x is equal to 5. And it's always a good idea to choose 2 or 3 values to check because sometimes you just get lucky where the first value works but the other ones don't. So at x is equal to 5, we're going to see if this works. We're going to start with our original equation. You always want to write that out. I'm saying add x equals 5, so I'm going to plug in 5 for x. Now we're going to do some calculations. Negative 2 times 5 is negative 10 plus 50. And negative 10 plus 50 is 40. So what I'm saying is when x is equal to 5 right here, the corresponding y value is 40, and that matches up with my table of values. And if I plugged in any of these x values, if I plugged in x is equal to 10, negative 2 times 10 is negative 20, and negative 20 plus 50 is 30. So it would also match up, and I know it works for all of these data points. And that's how you go from a table of values to making a linear equation.